this unit focuses on compound and absolute value inequalities. You may have done compound inequalities before back in Algebra 1 Honors if you remember it. So part of this might be review, part of it might be learning for the first time. Compound inequalities serves as the foundation for absolute value inequalities. So we'll do the compounds first, take a short break, and then start on absolute values. So, compound inequalities are inequalities that contain the word and or. So, and inequalities have this type of format. It looks like a three-part problem with a left, a middle, and a right. As far as the graph goes, all the shading is in between the two answers that you get. So compound inequalities means that you should have two parts to the answer, two numbers for your answer. So this is how a problem would be set up. This is how a graph would look. This is how the algebraic answer of it would look. Interval notation we'll take care of in a second. Or inequalities is very easy to tell an or inequality. It has the word or in it. So, or inequalities, when you have the answer, it looks like there's two separate answers. When you have the graph, it looks like there's two separate graphs. One going in, both of them going in opposite directions. So, in general, that's what an and inequality and an or inequality looks like. Now we'll delve into both of them individually. So let's start with an and inequality. And inequalities are simply two inequalities put together. So you have x is greater than or equal to -4, x is less than 3. So if you graph them separately, notice that there is one part of the graph that overlaps with each other. Two parts of the graph will be getting shaded twice. So this bottom part here is how the answer would look if you put them together. So you have x is greater than -4, going to the right, from left to right. X less than 3, going to the left. That's the part that overlaps. So all of your answers would be in that one little strip. For an and inequality, all of your answers are just those values that work for both inequalities. So notice you can write it using the word and, or you can write it in its combined format. I personally don't care which way you write it, although that format's the most common. That format's the most common. Now, as far as interval notation goes, so just a reminder, with interval notation, you use parentheses for less than, greater than, positive infinity, negative infinity, and you use the brackets for less than or equal to, greater than or equal to. So x greater than or equal to -4, you have -4 going all the way to positive infinity. So that's your interval notation. For x less than 3, get negative infinity going over to the 3. Notice that parentheses is on the 3 because of that less than sign. So when you write it in its combined format, you only have to worry about the parts in between. That was terrible. You don't have to worry about the parts in between. So -4 to 3, you use the numbers, and you use the signs attached to those numbers to determine the parentheses in the bracket. So a lot of this is just showing how the graph is put together. Graphing it is actually not very difficult. You're not drawing 3 different graphs. We're putting it all on one graph. This is just to show you how it's put together. So let me pause for a second and ask any questions before we do a graph ourselves. Alright, not saying I'm hearing, so let's go on to example 1. Alright, so to graph an and inequality, plot each value on the number line and shade in between. So it's about as simple as I can get it. Here's your number line. Put the 0 in the middle as a center point. -2 goes on the left. 5 goes on the right. -2 has a less than or equal to sign. So remember, less than or equal to, greater than or equal to, get closed circles. Five has a less than sign. Less than and greater than get open circles. Shaded between. There's your graph. So for interval notation, we only use the numbers. So -2 and 5. -2 has the less than or equal to symbol, so it gets a bracket. 5 has a less than sign only, it gets the parentheses. So there's your graph, there's the interval notation. We're done with problem number 1. Because all they asked was a graph. Questions before we move on to example 2? So when we have to solve them, and we're solving a compound inequality and it's and, we still solve to get the variable by itself. So notice that the variable is in the middle. Variable's in the middle. So to get the variable by itself, you would have to add 10. That cancels out. And then divide by 6. But if you're going to do it in the middle, you have to do it everywhere else. That means you have to do it on the left, and you have to do the same thing on the right. So whatever you do in the middle, you do on the left and right hand side of the problem. Whatever you do in the middle, you do it on the left and right hand sides. Any questions before we continue? So, there's our algebraic answer. Now we do our graph. Put our number line, 1 and 4. 1 has a less than sign next to it, so it gets an open circle. 4 is less than or equal to, it's a closed circle. You shade in between. And then your interval notation, 1 comma 4, 1 gets a parentheses, 4 gets a bracket. So there's all 3 parts of your answer. Questions on problem 2? If you have them, feel free to say it. Just closed mouth still don't get it. If not, then let me pause. So hopefully, if we did this problem correctly, you subtracted 7 on both sides. And then you divided everything by 2. So those are and inequalities. And inequalities, start from the middle, work your way out. You're shading in between. Or inequalities, a little bit different. So for an or inequality, you have 2 different inequalities, but notice this time they don't overlap. This time there's a gap. There's no overlap to it. So if you have an or inequality, how your graph should come out. You should have a gap. Now, if you're graphing them by themselves, the interval notation is still one single interval. This time, since it's a union, or are unions, so it means the problem has to satisfy one of the two parts of the problem. So for this interval notation, we do each interval separately, and then we combine them using what looks like the letter U. So this letter U simply means union. Simply means union. So or inequalities should look like they're shading in opposite directions. Your interval notation is 2 separate parts. So again, we're not drawing 3 different graphs. We're putting it all in one. So let's do this with example 4. Example 4, we have x is less than -1, or x is greater than 3. So we draw a number line. 0 is the center. So -1 will have an open circle, and since it's less than, shade to the left. X is greater than or equal to 3. You have your 3, closed circle, and you're shading to the right. So there's your graph. We get it correctly, we've got a gap. For interval notation, do each inequality separately. So x less than -1 would be -infinity to -1. Remember, the -1 has a parentheses because of the less than sign. X greater than or equal to 3. 3 to infinity. And then you put the union in between. There's your graph, there's your interval. Questions on example 4? Alright, just like the last one, let's do one together. Now I have you try one yourself. Example 5, you have 5x minus 4 less than or equal to 6, or -3x is less than -15. So, to solve it, you solve them like they're two separate problems. You're solving them like it's two separate problems. So for 5x minus 4 less than or equal to 6, add 4 to both sides. And then divide by 5. Yes.
Someone asked if you could scroll along.
Uh-huh. Is that enough, Brooklyn? Okay. Alright, so there's the first part. For the second part, you divide by -3. But remember, you're dividing by -3. You're dividing by a negative number, so you have to flip the inequality sign. Remember, that rule still applies. If you divide by a negative number, you must flip the inequality sign. If you divide by negative numbers, you're flipping the inequality sign. Any questions on the solve out? So now let's write it. The graph, here's your 0, 2, 5. 2 gets a closed circle. Straight to the left. 5 gets an open circle. Straight to the right. There's our graph. So for interval notation, you have two separate intervals. -infinity to 2. And a bracket. 5 to infinity. So there's your algebraic, there's your graph, there's your interval. There's your three parts. Questions before we continue? Alright, and let's see. Subtract 5, you get 3x less than or equal to 6, so x is less than or equal to 2. Add 7, and then divide by 5. So there's your algebraic, and then the graphing and the interval takes care of itself. So, now let's transition to an absolute value inequality. So absolute value inequalities come directly from a compound inequality. So absolute value inequalities, we don't solve it with the absolute value symbols. We convert it. Just like yesterday, we took an absolute value equation and separated it into two parts. Absolute value inequalities, we will rewrite it back into a different format. So the format you use depends on the sign that was given. So if you have a greater than or greater than or equal to sign, you are going to transform it into an or inequality. If you have a less than or equal to sign, you're going to transform it into an and inequality. So you first look at how it's represented, then convert it, and then you go about solving. So ors go with the greater than, ands go with the less than. And then once you rewrite it, you solve it in much the same way as we did the problems in the first half. So, any questions on what goes with what before we start in on some examples? I'll keep that right at the top there while we do examples 1 and 2. So, example 1, let's start with a simple one to kick us off. Absolute value of 3x is less than or equal to 9. So again, the sign is going to dictate how we convert this thing. So we have a less than or equal to symbol. So that means this is going to convert to an and inequality. So here's how we convert it. Whatever is inside of the absolute value, you bring straight down. The less than or equal to sign goes on each side. The number that came after it. First off, make sure that that's not negative. If it's negative, then this problem's over. It's no solution. You still can't take the absolute value of a number and get a negative answer. Take the number, write it once as a positive value, write it once as a negative value. Now, Mr. Lowe, you just said if it was negative, you can't do the problem. No. If I take the absolute value of negative 9, I get positive 9. So just like we did yesterday, you still have to account for both of those options. So you have to account for that option. So this is your conversion. Once it's converted, now you solve it just like we did in the first half of this lesson. So everything's going to get divided by 3. So you have negative 3 less than or equal to x less than or equal to 3. Any questions on the solving part? So then we graph it. Graphing the same as last time. Both of them are less than or equal to signs. So 2 closed circles. Shade in between. And your interval notation, negative 3 to 3, 2 brackets. That's everything associated with that problem. Any questions? Example 1.
What you said that 9 was negative 9, like you saw.
So before you convert it, if that 9, this 9 was negative, then we kill the problem. It can't be negative. It can be 0, it can be any positive number, but it can't be negative. So this green must be 0 or positive. Any other questions? Example 1. All right, and start solving out the problem. So the conversion is already set. Whatever's inside comes down, the sign goes on each side, the number, write it once as is, write it again as the opposite. So we add 1 to both sides, negative 6 less than 2x less than 8, divide by 2, negative 3 less than x less than 4. So there's your algebraic answer. And then your graph and interval notation follows from that. There's the graph. There's your interval notation. Any questions? Example 2. Alright, so examples 1 and 2, those involve less than and less than or equal to, which are conversions to and inequalities. So examples 3 and 4 are conversions to or inequalities. Let's see that message there. Why did we use or inequality for number 2? So we don't use an or inequality because of the sign that it started with. It's a less than sign. So less than and less than or equal to follows the and conversion. Greater than and greater than or equal to follow the or conversion. So hopefully that clears up that misconception. So again, absolute value, you got to pay attention to what that sign is, because that's going to dictate how you rewrite it. So example 3. So example 3, notice right off the bat, greater than sign. So this is going to get converted using the or inequality. But before we convert it, we have a little bit of business that needs to be taken care of. There's a 2 sitting in front of this problem. We need to get rid of it before we do any conversions. So, remember from yesterday, absolute values do not follow the distributive property. So we are not taking 2, we are not making it 2x minus 6. No, we're not doing that. divide by 2. So divide by 2 first. Get the absolute value isolated. Once the absolute value is isolated, this is how you do the conversion. So you do it once as is. X minus 3 greater than or equal to 6. Once as is. Second part is a little bit trickier. Inside the absolute value, you bring it down. The sign, flip it, the number, make it the opposite. So let me say that again. Inside the absolute value, you keep the sign, flip, the 6, you change it to its opposite. First part gets written as is. So, or inequalities, remember, have to go in opposite directions. This now will force it to go into opposite directions. If you didn't do that, they're going to go in the same direction. Any questions before we continue? Hopefully we know that as is and keep flip op is me just telling you what I do. Now we go about solving. So now we just solve problem. First inequality, add 3 to both sides. X is greater than or equal to 9. Second inequality, add 3 on both sides. X is less than or equal to negative 3. So there's your algebraic. That's your algebraic. So from your up there, your graph, 9, closed circle, shade to the right. Negative 3, open circle, shade to the left. That's your graph. So your interval, negative infinity to negative 3, union 9 to infinity. It should not. That's my fault. That turns to the right. Thank you for catching that. Any questions on example 3? So of course you're about to try number 4 yourself. So the one hint that I will give you to start this problem is you need to get rid of that 4. Get rid of 4 first. So that's my hint for you to start the problem. So multiply both sides by 4. That drops the 1/2 y minus 3 greater than 8. Now we can do our rewrite. So we write it once as is. And then we keep, flip, and take the opposite. First inequality, add 3, you get 1/2 y is greater than 11. Dividing by 1/2 is the same thing as multiplying times 2. So y is greater than 22. Now, if you got 5.5, you did it in the calculator and got 5.5, I already know what you did wrong. You didn't put 1/2 in parentheses. So if you're gonna throw it all in the calculator, put 1/2 in parentheses, so that the calculator knows what it's doing. Switch on over to the second part, add 3 on both sides. 1/2 y is less than -5. Divide by 1/2. So if you got negative 2.5 or negative 5/2, I know exactly what you did. You didn't put it in parentheses. Or 1/2. Dividing by 1/2 is the same thing as multiplying times 2. You should get negative 10. So there's the algebraic answer. Once you get the algebraic, the graph takes care of itself. And the intervals take care of itself. And that is that. Questions? Problem number 4. Again, I would really put the 1/2 in there just for you all to think that it's hard. It's not that hard. It's not that bad. Not that bad. So again, absolute value, inequalities. The main thing you have to pay attention to is what sign did you have at the start of the problem, because that's going to dictate how you rewrite it. Once you get it rewritten, then solving it is the easy part. That's what we did in the first half of class. So, any questions before we move to close? So that's a greater than or equal to sign. That's a greater than sign. So they line up with the or setup. So notice that the or setup, the first half of that, it's written completely as is. The second half of the setup, the part that's inside the absolute value, is exactly the same. That's the key. The greater than sign is changed to a less than sign. That's a flip. C going to negative C, that's the opposite. But that only applies if you start with a greater than or greater than or equal to sign. So there's a heavy importance on look at the problem first. Look at the problem, make sure you identify all the parts of the problem before delving right in to solve it. Because that sign is going to dictate how you solve it. I.e., don't rush to try to get it done. Look and see what's happening. That look and see takes off maybe 5 or 10 seconds.